All right, so I will start with this Glacial growth data platform for foundation models based on Apache Iceberg. A little bit about me. I work at IBM there for almost 20 years now. Started with consultancy, then product group, and now in research. I'm also involved with some open source activities in Linux Foundation. There's a project called Soda Foundation, which is related to data and storage. And I exist on social media as well. So before we start, I just want to get into some housekeeping on my side. So basically, this presentation, the talk I'm giving here is not related to any IBM product or service. This is a project internal to IBM called DMF. And DMF stands for Data and Model Factory. And this is a internal project in the research AI group where we do the foundation models, build the foundation models, and all kinds of works with foundation models. And when I say foundation models, these are basically language models, large language models, or code models. All right, so with that, let's get into what is there in the data and model factory ecosystem, what all is involved. So before we get into the details of that, I just want us to get on the same page in terms of what all is involved in foundation model training and the whole ecosystem around it. So first of all, you start with collecting the data. And after that, you do some sampling to see, the data is what you actually want. Then you go through all the cleaning process and annotate the data for certain things you find in the data. Then you filter out, the bad data which you don't want in your models. And then you go with the tokenization, and then the training starts, and after that, tuning, evaluation, and all that. So that's in general, at very high level, the overview of what all is involved in foundation model training. Now, indeed, this is a monumental effort, multi-million-dollar effort when you are building foundation models from scratch. And there are various teams involved. So from our perspective, Lakehouse is at the core of it because that's where all the data is stored. And the various teams which include the very first team actually is the data acquisition team. And this team is basically responsible for crawling the data, downloading the data, even purchasing the data if needed. And then at the very early stage, basically what they do is remove all the multimedia content because we are dealing with the language models, right? So all we need is text. So basically remove images, sound, and audio stuff and all that, right? So once you have the text extracted data for the data set you are downloading, acquiring, then you insert that data in the Lakehouse. That goes in as a data set and has a bunch of metadata with it, from when it was downloaded, what are the licensing terms, and blah, blah, and the actual content. So that's actually the first thing which gets the data in the Lakehouse. Then comes governance, which is very important from the company perspective because there is legal involved here in terms of, the data you are actually using, you are allowed to use that. So they do some sampling, explore the data, and a separate process goes through in terms of clearance. And alongside, there's this huge setup of doing the pre-processing of the data. Now you have multiple data sets. and you keep acquiring more and more, right? And these old data sets basically need further cleaning and a lot of other processing. And for example, first of all, you want to deduplicate. You don't want duplicate data to go into training, right? So deduplicate the exact same documents. Also fuzzy deduplicate. So there are other techniques to do fuzzy deduplication. Identify the language, because if you're training English language models, then you want only English. So that way you just identify the language of the content you are processing. HAP, which stands for hate, abuse, and profanity. So this is basically, you don't want bad language to go in your models. So identify HAP as well as PII, the personal information, in the documents, and annotate the document that, this is what we are finding. So, and also assess the document quality. So all this actually themselves, some of this actually themselves need different models, AI models, to do the processing. So this is actually quite a huge setup where you process large amount of data and do all these annotations, and then after that you would do the filtering. So all this is done by reading the data from datasets from the lakehouse. And as part of this process, you actually generate output data, which is also stored in the lakehouse. So that's basically a huge task of data preprocessing, or also called data engineering. Then comes, once the data is ready, cleaned up, it is filtered, then it is basically ready for tokenization. And then comes the model engineering team, which would take this cleaned up data and tokenize it. And then basically train the models. And this itself is a iterative process, because in one shot you can't get the model right. So this is quite involved also. But I want to clarify that the tokens are not stored in Lakehouse, and therefore the training is actually not done directly from Lakehouse. So that is a piece we are still working on and trying to figure out how we can do some kind of data loader for the model engineering team. But right now, they have some strict requirements which we do not meet from the Lakehouse perspective. So they do it on their own. But because there are a lot of experiments happening as part of this engineering model training part, this experiments in terms of what was used, what was produced, what was the result, that is stored in the Lakehouse. And that is true for if it is a instruct model, you basically also, after training, tune the model for following the instructions, right? So that it, for example, if it is a chat model, it will do the proper chatting with you. So there's also quite a bit of involvement, multiple experiments actually that run when you do instruct tune a model. And those experiments and the experiment results are stored in the Lakehouse as well. Then you do, of course, test, and then the models are released. The models released in the sense that they are ready to be consumed by certain teams, not everybody yet, because you still have to go through a long process of evaluating and all that. So these models actually are stored in the Lakehouse, and I will get into details how they are stored in the Lakehouse. But we have this mechanism that the models are stored in the Lakehouse such that they can be shared with the other team on a selective basis, on a approval basis. So that's the model part. Then comes the model evaluation. Evaluation itself needs evaluation datasets, and those evaluation datasets are stored in the Lakehouse. They do the evaluation on their own platform. Results are pushed back in the lakehouse as well. Now, if the people are happy with the evaluation results, then there are actually teams within the company which actually work on the different product offerings of the existing product offerings, right? And now we want to infuse AI in those products. So this product infusion teams, multiple of them, they actually, what they do basically is that, in simple terms, they fine tune the model for their specific area, so that the model is expert in that particular product, right? So these are different teams. They need and they have their own data sets, basically, because these are product specific data sets, and they use these models and produce the fine-tuned model. And this again requires data sets, and the output is models. Input is model, as well as output is a new model. So these are also stored in the lakehouse. And then there are several other research teams which do experiments on their own, like distributed training versus how you can optimize or get better response from the models, better in the sense latency-wise, faster response. So there are several different teams which do different kind of experiments. So they need a central place as well, and Lakehouse is the one. Above all this is a user interface, which actually is kind of a executive dashboard, where you can see different data sets, different models, which models used which data sets, because that is very important, even from legal perspective, because if you want to track down, right, which data set was used in which model for whatever reasons down the road, you should have the full lineage of that. So you get all that through this user interface as well. And basically, yeah, so what we have here is a central repository for all your data and models in the Lakehouse. So that's the whole, the project we are talking about, and we call it DMF. Now, in terms of the architecture, what we have, all of our data, which is actually in Parquet format, is stored in object store. We use IBM Cloud Object Store. So everything is there in IBM Cloud. We allow people to actually bring their own clusters. So we don't provide any compute. So people bring in their own Spark clusters, their own Ray clusters. And we started with Flink initially, but we don't actually use it anymore. We don't have that kind of streaming needs right now. So mostly it's Spark or Ray. And you can have individuals doing work on their laptops, right? So you need a Python library. So we have something called DMF library, which is a Python library. Majority of our work is here. We use Iceberg REST catalog, and very happy with it. We don't modify it, but what we do actually is we have something called Lakehouse proxy, which sits on top of it, before it. So all the requests actually come to this proxy, and this takes care of a lot of things, which I will explain later. Then we do also use for authorization. Actually, we use SpiceDB, and I will get into details as well. But SpiceDB is one layer of where we store the policies, the authorization policies. We do maintenance. We have this whole viewer of your Lakehouse, what all it contains. And also we use Kafka Connect for certain things. Now, in order to actually visualize the data, all of the data here, through the query engine, we have this superset, open source superset as is pretty much. And people are able to just query their data as on an ad hoc basis, basically. So yeah, and then they build their own charts and whatnot, right? So this is one layer where you actually have the visualization of all your data existing in the lakehouse. And this is actually quite access controlled in the sense you see only what you're allowed to see. Now, the other part I mentioned is the user interface. And this is where it's kind of an executive dashboard, right? So we don't have full data available here in the user interface, but we have some sampling done, and then that is what is available in the user interface. So this is the overall picture of what the setup we have. In terms of what the lakehouse contains, I think you already got the idea that all the data sets, text extracted data for language, for different languages and versions. Because once you have the data set down the road after a few months may get new version. So there are new versions of the data sets as well. And then of course, as I mentioned, there's a legal clearance and all that involved with that. The data engineering team, the preprocessing team, does a lot of processing of the data, and that data is stored in the lakehouse, as I already mentioned. And then, of course, the models. With models, you get the model cards and some more information about how to use models and all that. So that's available through lakehouse as well. We are over 1 petabyte now with over 100 namespaces right now. And this is all text extracted data. If you don't consider text extracted, then it is several petabytes. But what we store in Iceberg Lakehouse is text extracted data. All right. So in terms of the features we have, this is the list. I won't read it, but I will go through most of this in the next few slides. Overall, this is basically a single database for all your data as well as models in the company. Okay, so the first thing is authentication, and we use OAuth token-based authentication. Pretty straightforward. You go to our user interface, get a token based on your authentication to that interface, and that token is what you carry in any cluster you are using. Even if you're using like your simple library on your laptop, that's the token, all you need. And it's pretty straightforward. You just get the token, which expires after certain days, and then you go from there, right? So, and as I mentioned, we actually, in this case, we are not using OAuth in the REST itself catalog. It's taken care in the Lakehouse proxy. Now, the very important one is the authorization. As I mentioned, that we allow people to bring their own compute engines, Spark, Ray, and whatnot. And even from Superset, people actually will log in with their ID, and they should see only what they're allowed to see, right? So all that is taken care by our authorization service, which I had mentioned just now. And this authorization service here, and this leg proxy, right? So come on. So on this, basically, there are two levels of control. So first of all, you define that a user has read access or write access on a table. And that is something defined and stored in SpiceDB. As I mentioned, SpiceDB is basically a API-based service which allows you to define relation-based access control, a fine-grained access control for any resources. So it's basically a mapping between a user or a group and the resources. So that relationship is stored in SpiceDB. And what we do internally is that we convert that into the corresponding access policy on the object store. So whenever a request comes that I want to read data from this table, for example, it will go to this catalog, of course, right? And before catalog, we will intercept it in our authorization service through proxy, determine if user has access or not, and then user will be allowed to actually go or not to the object store, just using the token. So that's the high level concept. Basically, it's no matter from where you come, your access is controlled at the storage level. Now, that actually gives us a very good capability in terms of multi-tenancy. So we have different teams, as I mentioned, and each team get their own namespace. We call it team spaces. And in that namespace, they basically can have their private data sets, tables, and models. And also, they can have shareable data sets and models, or even tables. So what shareable means is that you put those in a specific table, and then that table can be shared with other teams or other team members, basically. So this is a very useful feature, and is quite nicely adopted, because various teams have this kind of requirement that they want to work in their private space, and then also they want to sometimes share outside of their teams. So this is quite useful and totally based on the authorization mechanism we have put in place. Also, the team admin gets the ability to assign members within that particular team. So that way, we don't have to get into the business of managing users and all that all the time. I mentioned that we also store models in Lakehouse, models and checkpoints. Now, when the team is working on experimentation and all that, they keep the models private in their private namespace, basically. And when they think that the model is ready to be shared with other people, they move the models to the shared table, basically. Now, we don't actually store models in the Iceberg table. We store model metadata in the table, like this picture shows here. This Granite models, by the way, we open sourced some of the Granite models last week, 4 of them. So these models are actually, the metadata is stored in the Iceberg table. But using our API, you basically do model push, and this basically generates this entry in the table. But also it stores the files, the model files, in the object store, and keeps the location here. Now, these model files are access controlled exactly the same way as our tables are. So we use the same access control mechanism, no difference there, and you get the same control mechanism. So basically, whether it is models or whether it is model files or whether it is tables, they use the same authorization mechanism. All right, and okay, so the next thing I want to get into a little fast is change monitoring. Anything happening in Lakehouse, we need to know. So one reason is, of course, auditing, and other is maybe in some cases you want to act upon certain change. So in that case, you know, because we have this authorization service and the proxy in front of our catalog, right? So with the user token, any request coming in, whether it is, anything to do with the tables, right? Or even models, we intercept that, and based on that, what is coming in, we figure out that what kind of operation it is, on what resource, at what timestamp. And this is where we use Kafka Connect. And so it goes actually through Kafka Connect. In case of auditing, we just store the records in audit log table. And in case we want to work on a specific change to do something, so there are jobs which listen to this particular topic. And if the change is of interest for the specific job, and they would act on it. An example of it is basically update the UI backend database for a change happening in a particular Iceberg table. This is the case when you want to instantly see, rather than waiting for sampling job to finish, right? You instantly want to see some change happening, like a new model has arrived, right? So if you want to see that kind of thing, then you would have this kind of instant use of that data. So that's auditing and change monitoring done in the Lakehouse today. Lake Viewer is a very useful tool, which actually gives you the complete view of what is available in the Lakehouse. So it shows you, if I can, for example, it shows you all the different namespaces available, and in a specific namespace, what are the different tables available. And then for a specific table, you can see all the different fields with their data types. And these are basically, Iceberg properties. You get to see what is the sorting order, what are the different references, all the different snapshots. Very much interesting for people is, how many records are there right now? What is the total file size? How many files are there? We also have this kind of partition statistics, which shows what are the different partitions available. These are the partition values. And for each partition, this is a small table, but for each partition, what are the record counts, how many files are there, and what are the file sizes. What is very useful is that when you click on any of this partition, you see the data for that specific partition. So this is an example of a particular thing. And yeah, you can actually select different partitions. So you basically get a very good view of your table in terms of what is there in the table. This is mostly based on PyIceberg. It's a very simple application, but very useful, because when people actually interact with Lakehouse, they want to see, instead of writing code or query to check what has happened, what I have done, they actually want to go in this kind of UI and just see it. And it's very fast because it's just using PyIceberg. And some of we also use DuckDB in some cases, because getting this kind of data out is not straightforward, not easy, and fast enough today. So, and this is actually quite independent from our rest of the stuff, and this is something we can open source as well. But as you know, it is pretty straightforward. Okay, the next thing, as I mentioned, there's a lot of experiments happening, and we do actually track these experiments in Lakehouse. And I talked about during model training phase and instruct tuning, there are experiments happening. There is something called, when you do model alignment, and you align actually sometimes with the synthetic data. And this synthetic data is actually generated out of some very small seed data, um, and some model is used. Some existing large language model is used along with the seed data to generate the synthetic data. Now, which seed data was used, which model was used to generate a specific synthetic data, all this kind of lineage is very important, because otherwise you lose track of it. And then with this synthetic data, which model was aligned, because a model A was aligned with it and model B was not aligned with it. So you have to keep track of all this, and this is where Lakehouse actually brings in a lot of value, because otherwise it gets really messy really quickly. So all this is stored in Lakehouse, and this is one way of tracking your experiments as well as real work for anything you do with the models and the data. It's basically going to give you a graph kind of output in the end if you want to track the whole lineage from where you started and where you have the final model. The next thing is table maintenance. I think this is pretty straightforward. Actually, most of our tables, when the acquisition team loads them as data sets, they are optimized from the beginning. They don't change much, the large ones, because they are quite static. You don't update those kind of tables. Only thing you do is that over time you may append more data to it, and then that is also usually a new partition and optimized in advance, basically. So most of the time that's the case, but then there are some smaller tables which actually get updates or inserts, like few records at a time, and those do need maintenance. And this is, I think, pretty straightforward nowadays, that you basically define this thing in table properties, that this table requires maintenance, and what kind of other properties for the maintenance. And then we have this job running, which figures out that, okay, this table needs maintenance, so let's do it. So it's straightforward right now. It's working well for our needs right now. So that's the maintenance part of it. And I mentioned a few times that we have this Python library called DMF library, including CLI. So you can actually do this kind of operations. Of course, it's Python library, so very easy to install. But also, all you need is your token to interact with the DMF platform. And what we have is basically the commands are like, pull or push datasets or list datasets, pull or push or list models. And same with the tables and the namespaces. So completely, all the actions you can do on Lakehouse can be done using this library. And it is, this is, we use it in other frameworks, like Ray is an example of it, right? Because it's all Python, and you need this kind of library for dealing with that. And speaking of that, so we do have all the data engineering work I mentioned actually happens on Ray framework. Now that work is actually done such that that team uses Parquet files, because Ray is not as simple as Spark is in terms of processing the data. You do have to size it very precisely to get the most out of it and most out of your infrastructure. So in order to size the Ray cluster, you need information about what kind of processing you are doing and what are the details of the data you are being processed. So for example, what are the file sizes, a particular column I'm interested in, what are the the sizes for that column, minimum, maximum, and all that, right? And then because, as I mentioned, they work with files directly. For each file, I want to know the details. So this is actually where Iceberg metadata comes handy. You get all the details right away. You don't have to do anything. And with our library, we provide that, and then they size the cluster accordingly, and then they process the files, because we provide the list of files and location, and then we actually write the files back. So this is actually something we implemented last year, even before Iceberg had the right support. And very early, we figured out that we can actually do it this way, because then we are dealing with files directly, and we do handle partitions accordingly as well in this case. So that's right. And a couple of other things I would like to mention is streaming. This is very encouraging when we have tried it. It is not in our production yet, but this is something we are working on, and early on, very good results. It's implemented in Python, but we are thinking of moving to Rust for this, which would get us even better results. I know we're short on time, so I'll go quickly. The next thing is Llama Index and LangChain integration also, which is, interestingly, you don't have to do much. All you need from a data perspective is a data reader for your underlying data set. So in our case, we're using our library, so we call it DMF reader, but it could be simply as Iceberg reader. So a few weeks ago, I checked, it wasn't there. That's something we may be able to contribute as well. So after that, whatever it does is all their own ecosystem, their own framework. But this is one interesting thing I think which should exist for Iceberg as well. And what else we would like? We love Iceberg. It's working great for us. It would be nice to have a JSON document, JSON data type in the Iceberg. Indexing, we can build our own. We haven't yet, but it would be nice to have an open source effort on that. Very interesting in PyIceberg, but if it supports, if it is adopting Rust as its backend engine, that would be even more powerful. We like Spark's storage partition joins. It changed basically, how it was before and after. So storage partition joins are great for Spark, and thanks for the team who worked on it. But it's Spark only. We want this to be, something more generic, and support other file types easily, which is, I think it is not that easy right now. So, and I'm particularly looking for Lance file type. So that's something it would be nice to have. So happy to discuss more on that as well. And I think that is end of it. Thank you, and I'll take any questions.
Yeah, thank you. I got great presentation. I have one comment. Is in Iceberg we also have Iceberg Rust, so maybe you can experiment this. For supporting JSON data type, that will require a spec update. So I don't say it's not possible, but it's a long process because it has a huge impact of engine extra. So something that definitely we can discuss. We are a little short on time, but we got some questions. So I wanted to focus on a couple of questions dedicated on Iceberg. So the first question is, what volume of data are you updating in the Iceberg tables, and how is the performances?
In terms of table updates?
Yeah.
Very, very little. As I mentioned, all of our data sets basically are static. Only thing we get is the append, which is kind of a new partition. Um, Now, update happens like as you have seen, like audit log, right? That kind of thing happens, and Kafka Connect handles it. That's every 10 minutes we dump the data in the table. That's configuration on the Kafka Connect. There are very little updates otherwise. Mostly it's append, and no issues for us for that.
Okay, good to know. Other question is, would it be possible to partially allow part of the data to be accessed based on the timestamp, colon or something? That is quite handy for cases such as GDPR. What's your take on that?
Yes, definitely. And um, so here's the thing: for the jobs, they basically need the full data sets, so they don't have this need. But for our end users, or for the users who actually want to query the data by specific field, that's where the query engine comes in, right? So for that, we have that superset, and then it goes through the query engine. At the moment, the query engine handles it well. Of course, we have to experiment a lot with that, but totally relying on the query engine right now for that.
Gotcha. Another question is, what is Iceberg lacking that prevents it from being used for storing tokens?
Yes, there are multiple issues there. Of course, first of all, we have to write a PyTorch loader or a Megatron loader for Iceberg. But even then, I think the real issue um, is the latency. So what happens is that if a node fails a GPU cluster in the GPU cluster, right? Um, it needs to actually store the checkpoint, and if you're building a 50 billion token model, that's a lot of data. Now you want to actually store that checkpoint, and then quickly recover when the node comes back, right? And that requires you don't have actually that much. If you wait for 30 minutes for getting all the data in and out, that's a waste of time, a lot of time, right? So what they do today is that they don't use object store in that scenario. They have a GPFS or parallel file system, which is where they store all this. So it's actually quite disconnected from rest of the ecosystem right now. So that's the reason we are not in there yet, but then we are trying to figure out if we can do a Megatron loader for Iceberg and figure out some other optimized query for the tokens and training part.
Okay, well, that sounds good. Last question. Is model engineering team currently copy the data from Lakehouse to some kind of databases to do the further analysis and during model building?
Yes, as I mentioned, so they don't actually deal with data; they deal with tokens, and they do store those in the local. It's a cluster, but it's a local to the GPU cluster, um, called Spectrum Scale, or general parallel file system. It's a distributed file system.
Okay, nice. So yeah, we are out of time because new session starting now. So thanks again, Rakesh, for all the details and great presentation.